So here we go. We're talking about section 5.5 integration methods. And I've broken it down into a list of about 10 things you should try in order until you get really good, right? Try step 1. If that doesn't work, try step 2, try step 3, right? That type of thing. And as we move forward in chapter 5, we're going to add another 5 or so integration methods. So we'll have a list of 20 at the end. One of the main points of the whole course is even those 20 methods will eventually fail. And so in chapter 8, we learn this final method, which is turn the function into a series of polynomials. And of course, polynomials are very easy to integrate. And so that's the grand finale there. So our integration methods, our first one is it's a known integral, right? So the integral of f prime of x dx is f of x plus c. Right? Where y equals f of x plus c implies y prime equals f prime of x. So this is the nerd version. Sorry, where, not why. Right? And then the human version is we recognize the derivative. Right? We know f prime of x. So for example, the integral of e to the x dx. What function did I take a derivative of to get e to the x? E to the x, right? And then plus, right, that constant of integration. Is everybody comfortable with the constant of integration? Nice. So our first method is just look at the integral, right? Look at the argument of the integral, which by the way is in yellow, right? The argument of the integral is in yellow. And the operator of the integral is in green, right? So green is the operator. Right? That's telling me to integrate, undo the derivative with respect to x, right? So it's a little bit strange that the operator is in two pieces there, almost like a set of parens, right? And then the argument of what I'm looking at, the input of that integral function is that e to the x there, that yellow piece. Is that making sense what I'm saying? This is where the cameras help because I could either see you nod or you can touch your space bar and say yes, right? So, but it's important that I know that you're following me, right? And I don't care if it's a visual, if it's an audio, if it's a symbol, a symbolic thumbs up, or they don't give you they don't give you options of every finger. Only the thumb, right? Thank you, Sandra. So what if we had, the integral of cos of x dx? This is one we should know. Do you recognize what you took a derivative of to get cos?
Negative sin x.
Okay, so cos and sine. I'm thinking of an alphabet wheel. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, right? So derivatives go this way. So what did I take a derivative of to get to cosine? Follow my sine. And so when I'm coming backward, I'm doing antiderivatives. So this is sine of x plus c. How are we doing? We okay? Nice. The integral of 1 over 2 square roots of x dx. This one I'm saying you should recognize. If you don't recognize it, maybe one of our other methods will take care of it, and it will happen that way. If you don't recognize that this is a level 1 problem, and who cares about the numbers of my levels? No one does. If you don't recognize that this is something that you should you know what you took a derivative of here, another method should take care of it. Okay? So this one is what? Anybody know it?
The square root of x plus c.
Beautiful.
Integral of it.
Yep, that's it. So that particular one will work with method 2, which I'm ready to talk about now. Okay? So, but if I recognize the derivative, I should be able to tell you what the antiderivative is. And let me do one more because this is a weird one. What about the antiderivative of 1 over x? Do you recognize what you took a derivative of?
ln x.
Yeah, ln of x. Yes. Nima, Melky, yes. And so, but the antiderivative is absolute value, ln of absolute value of x. And I guess I better explain that. So when we undo the derivative of 1 over x, we got to use an absolute value. So let me explain, okay? If I'm starting with y equals ln of x, notice I have a function with only a positive domain. Right? It's because ln, right? I can't put a negative into the ln function, right? Everybody with me there? Anybody with me there? So when I take my derivative, I get y prime is 1 over x. Of course, 1 over x exists on both sides, but I don't care about the side with the negative domain because it's not in my original function anyway, right? If I want the slope at 1, 0, I get it from this height, right? So I don't care about the other part of 1 over x. So, but if I'm starting with 1 over x, now what's my domain? Everything but 0. All positives and negatives, but not 0, right? So if I'm talking about y prime is 1 over x, now I have to include the negatives, right? I have to include the negatives, which is why when I get to y equals ln of x, I need the absolute value. Because now I have negatives involved. So when I go plug them into my antiderivative, I got to make sure I kill the negatives, right? I got to make sure the negatives get canceled out. Does that make sense at all? I think the thing that you really should see is that if I have the ln of absolute value of x, and I write it as a piecewise function, that's ln of x for x greater than 0, and it's the ln of the opposite of x for x less than 0. So I'm writing it as a piecewise function, right? So I'm writing it as a function without an absolute value in it. So when they're positive, I don't need the absolute value. And when I'm negative, I need the opposite of the negative, right, in order to plug it in to make it the absolute value. And so let's call this first one y1, second one y2. What's y1 prime? Well, it's 1 over the inside times the derivative of the inside. So it's just 1 over x, check. And what's y2 prime? It's 1 over the inside times the derivative of the inside, which is also 1 over x. So it's really important that you see, right, that if I started originally with the ln of absolute value of x, when I take those derivatives, I still get 1 over x. How are we doing here? Most methods that we do will eventually turn into something that you recognize. Okay? It might be 11 steps. It might be 3 pages of work. But eventually it's going to come back to something that you recognize that you just have to take the derivative of. Okay? That you just know what you took the derivative of, right, to get the antiderivative. Okay, we're ready for our second out of 10 method here.